Day 3 of multiplying and dividing. We're about to enter the realm of decimals and fractions and tricky wording because they always got to make it tricky for you. All right, so here is an example of how it's not tricky. So I am being nice and easing into my explanation of the tricky part. So the product. Hopefully you remember from grade school what product means. Product means the answer to a multiplication problem. Remember this? Sum is the answer to an addition. Difference, answer to subtraction. Product, answer to multiplication. And the fourth one, you nailed it. Quotient, answer to division. So product, you see the word product, you think I got to multiply. So you have to multiply 4 and 8 together. Your answer is going to be 32. It doesn't matter. They could have wrote the problem, find the product. I'm just going to erase this to be faster. Find the product of 8 and 4. Your answer is still 32 because when you multiply, it doesn't matter which one comes first. 8 times 4 and 4 times 8 are both 32. So the wording here is not tricky, as long as you recognize that product means multiply. This is where it gets tricky, is when they use the word quotient. I just told you, if you might remember from less than a minute ago, that quotient means the answer to a division problem. So if they find the quotient of 4 and 8, or they might word it as find the quotient of 4 and 8, which I think I just said, but it actually read find the quotient of 8 and 4. So here's the two different ways. Now it does matter. If this said product, it didn't matter. Your answer is 32. But now that it says quotient, now the order matters. It could either be 2 or it could be a half. Meaning you could have 8 divided by 4, which is equal to 2 over 1, which is 2. 8 divided by 4 is 2. You might want to use your little house. 8 divided by 4 is 2. Some of you like that way. I like reducing fractions, but whatever. You're probably going to have to do it this way because we're going to get into decimals. All right, or you could say find the quotient of 4 and 8. That's 4 over 8, which is 1 over 2, 1 half. 8 goes into 4, 8 goes into 4 0 times. So you have to add a decimal and a 0, and 8 goes into 45 times. So you get 0.5. So if you're doing the division, the long division, you get 0.5. If you're reducing your fractions, you get a half, and a half and 0.5 are the same. What I'm trying to illustrate here is that order matters when the sentence says find the quotient of a number and another one. It does not matter when it says product. And to me, it's not like intuitive. I don't know, just by looking at this the first time I looked at it, what are they trying to tell me here? They want me to do 4 divided by 8 or 8 divided by 4? Like, I don't know. I can make an argument for either one. So you just have to, well, I guess you don't have to do it any given way. This is the way that I do it. I turn it into a fraction with the first number on top and the second number on bottom. 8 over 4, 4 over 8. Right, and then if I want to turn that fraction into a division problem, I know I'm always dividing the bottom number into the top number. This is saying 8 divided by 4, 4 divided by 8. And this is how you do 8 divided by 4. You put the 8 on the inside. You put the top number on the inside. Top number on the inside. This is 4 divided by 8. This is also 4 divided by 8. So when you see a sentence like that, and you're not sure which one goes inside your house and which one's out in the cold, maybe it's easy for you to remember that the number after the word and is outside the house. The number after the word of is inside the house. Maybe that's good enough for you. You got it. I can't remember that. So maybe you want to make a fraction. This is 8 over 4. That's the way I like to do it. So however you could come up with some kind of way to remember that this is 8 divided by 4. Maybe the and you think as a division symbol. Maybe and means divide. This is 8 divided by 4. This is 4 divided by 8. That might be a good way to do it. But you got to get that right. Because when you get to a test, 2 and 1/2 are both going to be answers. So if you can't remember which one goes inside the house and which one goes outside, or which one's on top of the fraction and which one's on the bottom, then you're just guessing. And nobody likes to guess on a test. You'd like to know for sure if you got it right. So that's one trick that you'll see pop up. Here's another one. Multiplying a decimal with a fraction. 2.2 times, I'll just use the dot this time, 1 1/2. Ugh, that looks ugly. How are you supposed to do 2.2 times 1 1/2? There really is no method that I'm aware of to multiply a decimal times a fraction. Let's start off with an easier fraction. 3/4. Okay, so back to where I was. How are you supposed to multiply a decimal times a fraction? Nah, there is no good way to just do that. So you have to convert it first. You have to make them the same format, meaning they either both have to be decimals or they both have to be fractions. Well, I strongly recommend you turn the fraction into a decimal. It's easier, first of all, to turn a fraction into a decimal than it is to turn a decimal into a fraction. And then the multiplication is usually easier as well. So I'm going to do it like this. 2.2, I'm going to do long multiplication. 2.2 times whatever 3/4 is as a fraction. And I picked an easy one, so hopefully everybody knows right off the top of their head that 3/4 is 0.75. Because you're splitting a dollar into 4 parts and taking 3 of them. That's 75 cents. Remember, the bottom number is how many total parts there are. The top number is how many you've got. If you split something into 4 equal parts, like a dollar, and you take 3 of those parts, that's 3/4. That's 75 cents. That's 0.75. Okay, that's thinking about it in your head, mental math. The actual formula to turn that into a decimal is to say 3 divided by 4. 3 divided by 4. And then you can say, well, 4 doesn't go into 3, so you add a decimal and a 0. 4 goes into 30 7 times, which is 28, with 2 left over. Bring down another 0, and 4 goes into 20 and even 5 times, so you get 0.75. And you may have to do that, because not all your fractions are going to be something that you just already know in your head. Like it might be 5/6. I'm not even sure right off the bat what 5/6 is as a decimal, so I'd probably have to do the long division just like you guys will. So that's the second trick. The first was knowing the difference between a quotient of 8 and 4 or a quotient of 4 and 8. The second trick is multiplying a decimal with a fraction, turn that fraction into a decimal. From here, I think you know how to do this. It's just 22 times 75, and then you'll move your decimal over 3 places at the end, because you have 1, 2, 3 numbers after your decimal. So you want me to show you that? 2 times 5 is 10, carry the 1, that's 11, put a 0. 7 times 2 is 14, carry the 1, 14 plus 1 is 15. Now you add 0, 5, 6, 1, and you have 1, 2, 3 numbers after your decimal and the 2 numbers that you're multiplying together. So you move it 3 spots, 1, 2, 3, and you get 1.65. The answer to that problem is 1.65. The third trick is that one of these numbers, or both of them, or some combination of them, may be negative. So we've already gone over that, so hopefully that's not too tricky. If one of them is negative, it turns your answer negative. If both of them are negative, your answer stays positive. Okay, now the third trick here, first was the wording of the sentence quotient and of. The second trick was turning a fraction into a decimal. And the third trick is you might have 3 numbers instead of 2. Ugh. So it might also be times -4 at the end. Okay. Actually, let's do this. It might be, well, let's make them all negative, because I haven't told you what happens if you have 3 negatives. I've always said if you have 1 negative, your answer is negative. If you have 2 negatives, your answer is positive. What happens if you have 3 negatives? Never mentioned that one before. So maybe some of you can guess. Maybe some of you just want me to tell you the answer. So I think I'll do that. I will tell you the answer to this one is going to be negative. But let me tell you what the number is going to be first. You would do this, everything we just did, exactly the same. You would get to this point right here. So you'd multiply the first 2 numbers together after you turn that into a decimal. Get this number, and then multiply that number times -4. So now you've got 1.65 times 4, and that's 20, carry the 2, 24, 26, carry the 2, that's a 6, and you have 2 numbers after your decimal, so that would be 6.6. Now we'll deal with the positives and negatives. So 6.6 is the answer. Now we just got to figure out is it positive or negative. I already told you it was negative, but now I'm going to explain why. Because when you multiply numbers, you only ever do 2 numbers at a time. So the first 2 numbers that we multiplied together were both negative. And you already know that a negative times a negative is a positive. So the answer to these first 2 multiplication, these 2 numbers when you multiplied was positive 1.65. Now you took this positive 1.65 and you multiplied it by the -4. So now you've got a positive times a negative. And a positive times a negative is a negative. So whenever you have 3 numbers in a row that you're multiplying and they're all negative, your answer is going to be negative because the first 2 are going to turn into a positive answer, and then you throw in that last negative and boom, it flips it back to negative. So you could have, let's say you had 11 numbers in a row and you're multiplying all of them and they're all negative. Do you have any idea what your answer would be, positive or negative? You got 11 negative numbers in a row that you're multiplying. Your answer will be negative. What if you have 12 negative numbers in a row that you're multiplying? Your answer is positive. How about 13 in a row? Negative. How about 14 in a row? Positive. Anybody picking up on the pattern here? The pattern is it's alternating, but more specifically, if you have an odd number of negatives, your answer is negative. If you have an even number of negatives, your answer is positive. Because if you have an even number, you can pair them up all in groups of 2, and they all make positive numbers. Like if you had 4 negatives in a row, these 2 would make a positive, these 2 would make a positive, and then you'd multiply those 2 positive answers together and get a positive. So if you have an even amount of negative numbers, you're going to have a positive answer because you can pair them all up and nobody's left out as the oddball all by themselves. But if you have an odd number, like say 5 negative numbers, say you got another one here, -7, that one's left out all there by itself, still a negative guy hanging out there by himself. These 2 will turn positive when you multiply them, these 2 will turn positive, but that one all by itself stays negative and it's going to turn those ones back to negative. So if you don't have somebody to match up with this odd guy out here, you're going to stay negative. But if everybody has somebody to match up with, they're happy and they turn positive. See how that works? Okay, so that was a lot, I admit. That was 3 things. That was a wording thing. That was turning a fraction into a decimal and multiplying it thing. And that was more than 2 numbers multiplied together thing. Is it positive or negative? So feel free to ask questions if they arise, because that was a lot of things.